Hey, and welcome back to our channel. It's been quite some time since I've discussed any content on the channel due to being very actively involved in extra lessons as well as teaching at school level. This evening we'll be looking at a question paper that's been set by the Department of Basic Education of South Africa. This paper was set for the November 2018 exams, as well as this paper focuses on grade 10, which is your paper 1 for grade 10. This paper, as well as many other papers, can be found on the Department of Education's website. So you can just go into their website, go into mathematics, grade 10, and the paper should be there with the marking guidelines to assist you. So what we'll do this evening is we'll go through the paper, we'll discuss it in depth, I'll show you exactly how to answer the questions, and you can use this as a practice run to prepare for your November exams. Basically what you'll find is the front cover page, then you'll find the instruction page, and then moving from there, your actual question paper will then start. Looking at this question paper, our first question focuses on factorization, as you can see over here, and it goes from question 1.1.1 all the way to point 3. So we'll discuss the first 3 questions in this paper, and then we'll move on to our next questions. Okay, let's jump into it. Hopefully this will assist you in a very good manner. So question 1.1.1, the question says factorize the following expressions fully. So they don't want an answer for x, they just want you to factorize it up until you have brackets, and that's it. So if you look at the following question as given to you here, you need to notice that you need to take out a highest common factor. So in this case, we'll take out x, and remember to always take out the lowest of the two. Remember, you can't take out more than what you initially have in this case. What we do then is we write whatever is left. So in this case, for this term, it will be 4. Bring the negative. You've taken a 3, so there will be 2 x's left in this case. The other thing that you need to pick up here now is that 4 is a perfect square. You've got a negative, and then you've got 2 x's, which means that this bracket is a perfect example of applying dots factorization, meaning the difference of 2 squares. So in this case, we give the x as is. We open up 2 brackets. If it's a negative, you'll obviously have a negative and a positive. Bring an x to this bracket, x to that bracket, and then all you do with the 4 is you square root it to give you 2 in each bracket, and there you've solved it. Okay. Question 1.1.2. We've got x squared plus 15x and minus 54. As you look at this question, you'll pick up that it's a normal trinomial question. First thing that you need to go and check for is what case does it fall under for trinomials. Remember, there are 3 cases. And what you initially have to do is go and look at the sign right at the back. If this is a positive sign, you will go to the front and use the signs obviously that are given to you in the front. As soon as the sign right at the back is negative, you need to understand that you need to open up 2 brackets. One will be positive and one would be negative. Split your x's up, and then you need to go and find the factors of 54 by saying 1 times 54, then carrying on to 2 times 27, etc, etc, etc. Once you've done that, you would notice that 3 times 18 will be a perfect match for what you need to do here. So once you've found your factors, you need to see which pair can I add together to give me positive 15 in this case. In this case, you can use 3 and 18. But remember, you're looking for positive numbers. You have to put the highest number with the positive and then the lowest number with the negative. So 18 minus 3 gives me positive 15. Positive times a negative is a negative. 18 times 3 gives me 54. There, done, dusted, sorted it out as quickly as possible. Okay, both of these questions that we just completed would be 2 marks. Obviously, they'll mark you on probably the x that you've taken out, and then combinedly, they'll mark you for the 2 brackets. In this case here, they'll give you 1 mark per bracket to give you to 2 marks. Okay, let's jump into our last question for 1.1. Our final question for 1.1 looks like this. It's 1.1.3. You'll have y minus x, y plus x minus y minus 1. Immediately, the first thing that needs to go into your mind is there are 4 terms, so we need to apply grouping in this case. So, with grouping, you create 2 identical brackets, what we call common brackets, where you then write one of the brackets, and then whatever you've taken out as the highest common factor, you will put into the other bracket. Okay, so in this case, we've got the following. Over here, we can take out a y, but firstly, let's group them. So this will go together. In between the 2 brackets, you always put a positive. X minus 1 in that bracket. So what are we initially looking for? We're looking for a bracket that will look like this. Or you could initially change it to look like what you will find in this bracket after you have taken out the highest common factor. In this case, the highest common factor is y. What you'll be left with is 1 minus x. Plus, remember, if there's nothing written here, there's always a 1. And then we've got x minus 1 in this bracket. Now, there's 2 ways you can do this. You can swap these 2 around, or you can swap this around and then obviously perform the sign change in your case. Okay? In my opinion, I will swap this around and perform the sign change. So what I mean by that is the bracket at the back must look identical to this bracket. So in this case, if I bring the 1 forward, it will be negative 1 plus x. Now to perform the sign change, I need to multiply everything from this sign onwards with a negative. So what I'll then get is y, 1 minus x there, that will change to a negative, to a positive, to a negative. Now I'll see that the 2 brackets are identical. Okay? What we'll then have is common brackets, where we write 1 bracket, and whatever's on the outside, we write in another bracket, and there you factorize fully using grouping in this case. Okay. Okay, let's continue to our next question. So our next question in this case, or in this regard, is 1.2, where they say simplify the following expressions fully. Simplification means to make it as small as possible, and if there are brackets involved, that the brackets should fall away. You need to find a way to get rid of the brackets. Okay, so let's jump into 1.2.1. So question 1.2.1 looks as follows. So we've got x plus 2, then we've got x squared minus, almost made a boo-boo, so minus x plus 3. Okay, as I see it here, this was factorized to form, or used in a way, or let me put it this way. So the factorization method used here was the sum of cubes. Okay, so what we need to do is we need to get rid of brackets. If you are found in a position where one bracket has 2 terms, you do the following. The first term in the bracket is multiplied with every single thing in the other bracket. You can see I did it at the top. And then the second number is then multiplied also with everything in the other bracket, but I do it at the bottom so you don't get confused. So first of all, we'll start off with x times x squared, which will give me x cubed. We'll then move on to the next one. Positive, negative is negative. X times x is x squared. Then positive, positive is positive. X times 3 is 3x. Sorted. Now we go to the bottom. Positive, positive stays positive, and then we get 2x squared. Positive, negative is negative. 2 times x is 2x. Positive, positive stays positive. 2 times 3 is then obviously 6 in this case. Okay. What you need to do now is find all the like terms. So this term will be on its own. This term and this term goes together. This term and the term there. And then obviously this term is on its own again. So you see how I make patterns under them so I don't get confused. So we'll have then x cubed negative x squared plus 2x squared gives me positive x squared or positive 1x squared. It's up to you on how you want to write it. Then 3 minus 2 is plus x or plus 1x. And then obviously the 6 on its own. And there you've solved question 1.2.1. Okay. Just make some space on the board. Then our next question, 1.2.2. We've got 5 over, what's that? X plus 3 minus 3 over 2 minus x. First things first, guys. Find an LCD. Find an LCD, and in this case, you would want to find something that both the denominators can change to. This is not just an easy thing. You physically need to go and sit and check. What does this denominator not have that this one has, and then vice versa? Okay? So in this case, if you look at this denominator, the denominator over here is x plus 3, but it needs a 2 minus x. And then if you go look at this, you've got the 2 minus x, but you need x plus 3. So at the end of the day, your LCD would then be x plus 3, then 2 minus x. There's your LCD. So in order to get your LCD the same, you need to do the following. But remember, what you do at the bottom, you obviously need to do at the top. So we've got the 5, x plus 3, then I've got the 2 minus x that I multiply the x plus 3 with. But what I multiply with at the bottom, I need to multiply with at the top. There we go. And then with this, I've got the negative 3 with the 2 minus x. And then x plus 3 is what I still need at the bottom here. Okay? So, whatever I multiplied with here, I need to multiply at the top with as well. And now we'll take it from there. So, moving on. Once your denominators are the same, you can write everything in the numerator positions over one denominator. Okay? The other thing that you need to be very careful of is the signs that might change as you continue with the question. Okay? So, as we move on, I'm going to write all the numerators over one denominator just to make it easy for you. We bring the sign up because it belongs to the 3, x plus 3, and then obviously we've got this massive denominator at the bottom. Now we need to distribute the 5 into the bracket. So distribute the 5 as well as the 3 into that bracket, but remember the negatives attached to it. So 5 times 2 is 10. positive, negative is negative, 5x. Negative, positive is negative, 3 times x is 3x. Negative, positive is negative, and then we get 9. And then you've got obviously the denominator that's over here. Now at the top, you need to go and look for the like terms and then simplify as far as you can. 10 minus 9 is 1. Negative 5 minus 3 gives me negative 8x. And that is then placed over x plus 3, 2 minus x in this case. And there you solved the fraction by simplifying it. Okay, let's move on. Okay, our next question is question 1.2.3. That question looks like this, and let me tell you, there's a lot of kids that struggle with this. So hopefully I can clarify everything for you so that you are able to do this. The only thing that you need to understand is that the difference between this question and another question that's similar to this is that they put a positive or a negative in between, and then you need to take out a common factor that you then get rid of and then solve until you get, or simplify until you get an answer. Okay? In this case, the first thing that you need to do is either break it up into prime factors or basically go and look at the prime numbers that you can work with to get the actual prime factors for the numbers. Okay. In this case, if you look at 25, obviously I've taught you the stuff on the grade 9. When I did the grade 9 and 8 syllabus, you take the 25, you put it into your calculator. Let me just see if my calculator is here and if it's functioning. It works. So we take 25, punch it into your calculator, press equal, shift, and then factorize, and it gives you 5 squared over there. That is the first step that you need to apply to solving this question. So what we'll then have is, in a bracket, 5 squared and the negative x at the on the outside. Multiplied, if you take the 3 of the 15 and you split it up, you'll then get the following: 3 times 5 x plus 1 on the outside. It's important that I put it in brackets, and I'll show you now why. And then obviously you got 3 to the power of x times 5 to the power of negative x over there. The important thing of putting this in brackets is to make you understand that whatever's written on the outside needs to be attached to the 3 as well as to the 5. So you need to multiply that with the exponent that's attached to that 3, which in this case is 1, and then 1 for the 5 as well. So if we carry on, you've got the 5 for the base. We then say a positive and a negative is negative. 2 times x gives me 2x. There we go. Times 1 times x is x. Positive is a positive. 1 times 1 is 1. Then we go to 5. Same story all the way. Then we've got 3 to the power of x times 5 to the power of negative x at the bottom. Okay. What we need to do now is apply law number 2. Okay? Because you want to get rid of the exponents as soon as possible, especially the variables in this case. Okay? So, we'll start off with the base of 5. We'll start off with the first one, which is negative 2x. The next one we've got is plus x plus 1, which is this story over here that we've got. And then we've got the x at the bottom. Okay? But if we bring the x to the top, it changes to a positive. It's like applying law number 6. Then multiplied by 3. At the bottom we've got, I meant at the top. At the top we've got x plus 1. At the bottom we've got positive x, but when we bring it to the top, it becomes negative, applying law 6 in an inverse manner. So what you then do is, you write the base of 5, we then say negative 2 plus 1 is 0, so we've got 1 left. Then x minus x, 0. Then we've got 3 to the power of 1. If you multiply these two with one another, you get an answer of 15. So basically in this question, if you get to an answer where you did not get rid of the variables in order to get a solid whole number or integer, you are sitting with a big problem. Then it means you've made a mistake here somewhere in this regard. Okay, good guys, we are done with 1.2. Let's carry on with 1.3, and once we're done with 1.3, we will continue to question number 2. Question 1.3. It says they determine the value of, and then they give you the sum if, sorry, my nose got itchy, if that is equal to 12 and then PQ is equal to negative 3. Okay, first things first, we need to write down this expression over here. So 1.3, here we go. So 3P plus Q squared. First things first that you need to pick up is the following. Is that the expression given to you here is equal to the following. 9p squared plus q equals 12. Well, not 12 in this case, but we'll modify it. So what I'm basically telling you is that we'll take this bracket, write it out twice, because that's what the exponent tells you to do. And then you'll go to apply foiling. Now we'll FOIL. First, outer, inner, last. Grade 9 stuff that was taught to you. You'll get 9p squared. You'll get plus 3pq plus 3pq again plus q squared. If you go and simplify, you'll get 9p squared plus 6pq plus q squared in this case. Okay. Now, what they want you to do is they want you to take the negative 3, because now you've got pq over here. Okay. They told you that 9pq, what am I saying? 9p squared plus q squared is equal to 12. And then they said to you that pq is equal to negative 3. So, this is how you do it. What we do is, we take the 9p squared and we bring the pq to one side. That's isolated now. Plus. Okay. So 9pq, what am I saying again? 9p squared plus q squared. They told you here is equal to 12. So what we do is we substitute the 12 in there. And then the pq, they said is negative 3, which we substitute in there. So now you've got 12 plus the 6 minus the 3 there, or the negative 3 that you substitute in. You'll then get 12 plus negative 18. 12 minus 18 gives me negative 6. And there's your final answer. So basically what they wanted you to do is take the expression given to you, FOIL it, then you need to have the insight to see that, oh, I've got 9p squared plus q squared, and they said in the question that it's equal to 12. Oh, I also have PQ. They say that's equal to -3. And then take that and go solve to get -6 in this case. So basically what they're testing here is the ability for you to recognize what you're working with and then to apply what they've given to you. Okay, so that is question 1.3. Question number 2. Question number 2 over here, we've got 2.1 where they say solve for x. So let's jump in there and solve for x as quickly as we can. 2.1.1. So 2.1.1, we've got px plus qx equals a. There we go. So what do they want us to do? They said solve for x, which means I need to make x the subject in this regard. So what I need to do firstly, I can't put an equal there because it's an equation. I need to take out x. What I've got left is p plus q equals a. In this case, a is the subject. I don't want a to be the subject. I want x to be the subject. So I divide by pq. But when I do one side, I need to do the other side. This will cancel out. So therefore, x is then equal to a over pq. And there's your final answer. Also note that p cannot be equal to -q. Otherwise, you'll sit with an answer that is undefined. Okay, but there it is. What this question requires of you is to actually make x the subject. So there you solve for x. So the answer for x would be a over p plus q. Okay. 2.1.2. There we go. 2.1.2, they give you 2x squared minus 5x plus 2 equals 0. So we've done factorization. I've done a full video on special factorization types. If it's not there, I will see if I can put a link in the description so that you can just follow through with that. Trinomial, you cannot get rid of the 2 by taking out the highest common factor because 2 doesn't go into 5 evenly. So in this case, we do the following. 2 brackets. You'll go and look at what you've got at the back. It's a positive, so we go to the front, which is negative, so both will be negative. First things first, let's look at this. You'll split it up. So you'll have 2x in the first bracket and only x in the second bracket. Okay? Then we need to go and look at what we need to put into these brackets. So we go find the factors of 2, 1 times 2, and then in this case we'll have 1, which is your lowest number here, and then 2, which is your highest number there. So therefore, 2x minus 1 is equal to 0, or x minus 2 is equal to 0. So what we'll then get is that 2x is equal to positive 1, x is equal to 2, so x is then equal to 1 over 2 in this case. And there we've got this question factorized fully in this regard. Okay. Then 2.1.3. 2.1.3 gives us the following. So in a bracket or half, 3x plus 1 equals 32. First things first, you want to get rid of that fraction. You guys despise fractions. I know kids these days, you do not want to work with a fraction. So in this case, we get rid of the fraction. And how do we do that? We take law number 6 and we reverse it. So if I reverse law number 6 for exponents, I'll get 2 to the power of negative 1, 3x plus 1, and then the 32 on that side. Okay. Next step, multiply whatever's on the outside with the exponent on the inside. And then take this and break it into prime factors, because what you're looking at is an exponential equation that was taught to you in grade 8 and in grade 9. So what we then have is negative positive is negative, 1 times 3 is 3x, negative positive is negative, 1 times 1 is 1. And then if you break up the 32 into your prime factors, which is obviously 32 equals shift factorize on your calculator, you will get 2 to the power of 5. Bases are the same, so they fall away, and then you'll have negative 3x minus 1 equals 5 to work with. Carry the 1 over, you'll get negative 3x equals 5 plus 1. Negative 3x is equal to 6. Divide both sides by negative 3. And you'll get, therefore, that x is equal to negative 2 in this case. Simple equation. Stuff that you guys have been taught in grade 8 and 9. All you have to do is just apply it again. Okay. Then, we are done with question 2.1. We are moving into 2.2. If you look at it, you'll see that for question 2.2, they gave you an inequality. Oh, I love inequalities. Because you need to know that if you divide or multiply by a negative sign, that the greater than or less than signs switch around from their original positions. So, let's have a look at question 2.2.1. So, 2.2.1, negative 11, then 3m minus 8, and then that is 4. That's what they give to you. That's the inequality they give to you. Your main objective in this regard is to get rid of every single thing that's in the middle except the variable. Because at the end of the day, you are going to have to go and draw a number line, or they're going to ask you to write down the numbers of integers that satisfy the inequality. Okay? So, first things first, I need to get rid of the 8, which means I need to add an 8. So I add 8 there, but what I do there, I need to do here, and I need to do it on the left side of the inequality as well. So negative 11 plus 8 gives me negative 3. Signs stay exactly as they were, but now I eliminate the negative 8. Okay, 3m is left, 4 plus 8 is 12. What I need to do now is I need to get rid of the 3. What I do with that is I divide everything by 3. Keeping in mind that I'm not dividing by a negative, which means the signs will still face the same direction. So, this will give me negative 1, this will give me m, and then this will give me 4. There we go. That's it. Inequality solved, full marks. If it was negative, and you divide it by a negative, the signs would just swap over to the other side. Okay. Then, this will lead us to move on to 2.2.2. In this case, for 2.2.2, they ask you to hence write down the number of integers that satisfy the inequality. The number of integers that satisfy the inequality. From negative 1 to 4. How many integers are there? There are 5 integers that satisfy it. From negative 1 to 4. So, if I had to draw a number line, negative 1, 0, 1, 2, 3, 4. What a number line. The number of jumps that I'll make would be 1, 2, 3, 4, 5. That's the number of integers that will satisfy the inequality. Okay. Good. Let's move on to our question 2.3. And they say solve simultaneously for x and y. Guys, simultaneous equation. That's it. So you need to now go and pick up. Am I using substitution or am I using method of elimination? That's up to you. And that is up to the way that you see the simultaneous equation. First of all, I'm going to write the equations down for myself just to keep my sanity intact. That's equation 1. And then I've got 2x equals 3 minus y, equation number 2. There we go. So, first things first, if you were me, which you are not, I would make y the subject in this case, and then use the method of substitution. Reason for this is because I do not need to eliminate any variables in order to get y on its own. I can just basically take the second equation and make a third equation. That's it. So how do I do that? I basically take that, throw it over to the left side, and take the 2x and throw it over to the right side. And remember to change your signs. So therefore, I've got y equals 3 minus 2x, and there is equation number 3, which for substitution is something that you initially need. Okay. So, next thing I'll do is I will take the equation, and I'll take the third equation, and I'll sub the third equation into the first equation. The reason why I substitute the third one into the first one is because I took the second one and I modified it to get the third one. Okay, so what I do is I say sub 3 into 1, which what I do now is the following. I say 5x plus 4y is equal to 21. Now when I substitute, you must understand that I've got y's value already. So I just say, what am I doing here? Oh my goodness. Plus 4. So I then say 3 minus 2x is substituted into y, which gives me 21. Now I need to go and distribute because I want to work with x in order to get a value for x. So 5x plus 12 in this case. And then a positive negative is a negative. 4 times 2 is 8x equals 21. What I do then is I move all the apples to one side, all the pears to the other side in order to get the variables on one side and all the constants on the other side, which will then have 5x minus 8x equals 21 minus 12 in this case. I'll then have negative 3x over here, and then over there I'll have 9 divide by negative 3 divide by negative 3, therefore x is equal to negative 3. So now you've got a value for 3, for x I mean. Once you have the value for x, you take that value for x and you sub it into 3. You can sub it into 3, you can sub it into 2, whatever fancies your method. Okay? So what I'm going to do is I'm going to take the x value and I'm going to sub into 3. I'm going to do it here at the bottom. So I've got y is equal to 3 minus 2x, and the reason why I chose the third equation is because y is already a subject on its own. So you don't have to stress to go and make it the subject and to throw a lot of things around in order to make it work for you. So the x value is negative 3, so y is therefore equal to the following. Negative and negative is positive, 2 times 3 is 6, 3 plus 6 gives me 9. And then remember to end your simultaneous equation as a ordinate in this case. And then you solve your simultaneous equation through means of substitution. Okay, let's go to question number 3. You can see I'm keeping you guys busy with this video today. Question number 3 is all about patterns. There's your sequence, and then they ask you a number of questions in this regard. Okay, question number 3. So my pattern is 20, it is 17, it's 14, then they leave it open, and then they give me negative 103. Beautiful. Okay, so what do we do? The first thing that you need to go and check for that they're asking question 3.1 is write down the fourth term of the pattern. The fourth term of the pattern. First thing you need to pick up is that this is position 1, 2, 3, 4, and then obviously carries on. You need to go find the constant difference, which is negative 3 in this case, because you have to subtract 3 every time to get the new number in the sequence. And if you do not know how to do this, I have numerous videos on the channel where I work with the grade 8s and 9s on patterns. Okay. So, this should be easy for you. 3.1, if you say 14 minus 3, term 4 should then be equal to 11, and that's 1 mark. That's a level 1 question. Okay. Then 3.2 says determine the expression for the nth term. If they speak about the nth term, or if they speak about the general rule, is they want you to go and find the formula that will get you the next terms or the next numbers in the pattern. Okay, so we start off with the following. We start off with Tn equals Bn plus C. It's up to you. You can also use the other formulas that they also use, that they give to you. In this case, you need to understand that when we go and find the general rule, you need to work with the difference, number 1, as well as the input, which is your position, and the output. So, in this case, the output is 20. The general, or not the general rule, the constant difference is negative 3. I substitute my position, which is 1, plus C, because I need to find the constant. I then have 20 minus 3 plus C, which becomes 23 in this case, so your constant is 23. Therefore, when I put my rule together, I should get negative 3n plus 23. And that is your general rule for this number pattern given to you over there. Then, question number 3.3, I'm going to do it right here. Sorry that if it feels that I'm all over. Calculate the number of terms in the sequence. Calculate the number of terms in the sequence. You then need to go and use the last number that's there to calculate the number of terms that they've got in the sequence all the way up to negative 103. Okay, so how do I do that? I say negative 103 equals, then I use my general rule, which is negative 3n plus 23. Negative 103 minus 23 equals negative 3n. And then I will get negative 126 equals negative 3n. If I go and divide both sides by negative 3, I will find therefore that n is equal to 42. So this value lies in position number 42. Okay. 3.4. Which term is the first to have a negative value? Oh my goodness. Some of you guys will panic now, eh? Which is the first term to have a negative value? I'm going to erase this. I'm going to keep the top. So, first things first. We want to know, this is for 3.4, which term is the first term to be less than 0. That's what we want to know. So, what do? We take the rule and we make the rule less than 0 to find that number. Okay? Now what do? Now we go and we put n on its own, meaning we do the following. You say negative 3n is smaller or less than negative 23 because we carry 23 over. You divide both sides by negative. N is therefore smaller than the following. You'll then get 23 over 3, which means if you divide 23 by 3, you should get the following. If you divide 23 by 3, you should get like 7,68 or something like that. Which means if you get that n is then equal to 7,67, that the first term to be smaller than 0 is then term number 8. So the value that is in the 8th position is therefore the first number to be a negative number in this case. Okay, the last one for question 3. 3.5. Number 3.5 asks for the following. What the hell did I just do here? 3.5 asks for the following. What is the value of the 19th even valued term? What is the value of the 19th even valued term? So, your general rule is the following. This is what we've calculated and established. Okay, the 19th even valued term. What is the value of the 19th even valued term? So, we need to go and work with term number 39 and then 37 in this case, which we then put in here, plus a 23. If you go and calculate all of this, you get the following. So negative 3 times, what's it, 37, will give you negative 111 plus 23. If you take negative 111 plus the 23, it will give you negative 88. So the 19th even value in this pattern or sequence is negative 88 in this case. Okay, sorted. There we go. Moving on to question number 4. Guys, I assume that we're almost halfway, or we are halfway already. They say Samantha is investigating a pattern of dots represented in the diagram below. Then they give you a geometric pattern. They say pattern 1, pattern 2, pattern 3, and they give you the number of dots. So 1 squared is 1, 1 plus 3 gives you 2 squared, which is 4, etc., etc. Then I'll ask you the following questions. Just have a look at that quickly before I carry on. And please keep in mind that each question for 4.1 is a mark out of 1. It should be a level 1 question. Easy peasy. Okay, cool. Question 4.1.1. They say, write down the number of dots in the 4th pattern. If you go and calculate it and you're squaring each pattern, you would then say 4 squared for the 4th position, and that will give you 16 dots. Done and dusted. Okay. Then 4.1.2, they say write down the number of dots in the 13th pattern. That's easy. You're squaring each position, so it's 13 squared, which gives you 169. There we go. Then 4.1.3, they say write down a formula for the number of dots in the nth position. Guys, you are squaring each position, so it's Tn equals n squared. There's your rule. Question 4.2, they say hence or otherwise calculate the value of the following. So for 4.2 they give you this. 1 plus 3 plus 5 plus 43. And they say, hence or otherwise calculate the value of that. So, first things first, you need to go and find the general rule for this. You need to find the general rule. 2n minus 1 will work. Because the difference here is 2 every time. 2 times the position minus 1 will give me 1. 2 times 2 is 4, minus 1 is 3. 2 times 3 is 6, minus 1 gives me 5. So therefore, the rule here is 2n minus 1. That's your general rule. They are asking you to calculate the value of the following pattern. So what we do then is, we take the general rule. We take the last value, which is 43, and we say 2n minus 1. We we make it 44 as you carry over the 1. Divide by 2. So therefore, n is then equal to 22 in that case. Which means then that position number 22, if you square it, should give you 484 as the value of that position. So that is the value of the number sequence that was given to you over there in this case. Good. We move on to question number 5, which would be graphs. Before I continue, I'd just like to take a sip of water because I've been talking the whole time. Please just excuse me. Alrighty, let's go. Here is our question, question number 5. Oh yes, I love hyperbolas and parabolas and your exponential graphs and everything else that comes with it. So, in this question, they give you the following. They tell you that the sketch below is the following. They give you the two graphs equations, and they say A and B are the x-intercepts of f. The graphs intersect at A and point E lies on F. C is the turning point of F and D is the y-intercept of G. If you look at the graph, you'll see that it's got a maximum turning point. So just keep that in mind. Then question 5.1. Question 5.1 asks us to write down the coordinates of D. Write down the coordinates of D. If you look at D, if you look at D, you'll see that D lies here at the bottom, where the graph comes in. It was not, it cuts the y-axis, which means that we've got, let me just see here, coordinates of D. There it is. Okay. So if you go right down the coordinates of D, you would find that D would be equal to 0 and negative 3 in this case, because it cuts the y axis at negative 3 in this case. Okay. So D would then be equal to 0 and negative 3, and the reason why it is 0 for the x value is because it cuts the y axis and it does not move the x left or right on the Cartesian plane. Then they ask you for the range of graph G for 5.1.2. My apologies. So if you look at the range of graph G, here's graph G over here. If you look at the range, you'll have to check where it basically starts and where it ends. And your range is measured with your y values. So the graph over here is graph G. Look at the Q value for it, which is the y-intercept. Sorry. Look at the Q value for the graph. And the Q value of the graph is what you then use to get the range. You'll also see that the graph comes from top left to bottom right, which means that the range would be y is greater than negative 4, because your graph moves from bottom right away to top left of the Cartesian plane. Okay. 5.2.1. Calculate the coordinates of A. You'll see that the coordinates of A is right over here where the two graphs intercept one another. You also need to keep in mind that point A lies on the x-axis which means that the y value is 0 and the x value is the thing that you now need to obviously go and calculate. So in my opinion, I would use the g function, meaning the exponential graph function in this case. So I would say gx is equal to a half to the power of x minus 4. I know that I need to calculate for x, and the fact that the graph cuts or intersects the x-axis means that the y value is 0 because the graph at that point has not moved up or down. So this is going to be 0. Then we'll have a half. Oh, why am I putting equal sign? Then, next thing that you'd want to do is get rid of the fraction. So we'll say 0 is equal to 2 to the power of negative 1, x, obviously law number 6. You see how the exponents come into everything that you do. Then what we'll do is the following. We'll get it as 0 equals 2 to the power of negative x minus 4. Carry 4 over to that side. You have 2 to the power of negative x. Make this or transform it into prime factors, which would be 2 squared, 2 to the power of negative x. So therefore, at the end of the day, x is equal to negative 2 in this case. So therefore, your a coordinate will then be negative 2 and 0 in this regard for question 5.2.1. Okay. Then they come with another question where they ask you to calculate the values of a and q. Now a and q is with function f in this case over here. Okay. So we write down what's at 5.2.2. So f x, what do we have there? Equals ax squared plus q. There we go. We need to calculate the value of, or the values of a as well as the values of q. So, on your actual question paper, on your graph, the f graph, you've got 2 points. These 2 points you'll use now to go and calculate the missing values here. So the 3 we'll put in there. We got a, the x value is 1, and then we've got plus q at the back, which doesn't have a value at the stage. What we'll do now is we'll have 3a plus q, which means that we've got one equation already. Okay, and we used point E, which is 1 and 3 in this case. Okay, what we do then is the following. We can use the points that we calculated in 5.2.1 for point A to assist us to, find the value for Q or for A in this case, and then also to create a second equation. So, point A's coordinates is negative 2 and 0, as we calculated in the first question for question 5.2. And what we're going to do now is we're going to take this equation that we've got here, and we're going to make a new equation. So, fx squared plus q. What we then do is we say 0. And then a negative 2 squared plus q. If you solve it, it's 0. And then it's 2a plus q over there. Okay? Which you can then go and do the following. Oh, sorry, it's not 2, it's 4. Because we have to square it, so 4. What you do then is you carry the 4 over, which becomes negative 4a, and that's equal to q. So now you've got a value for q in this case. Okay? So what we do now is the following. So this is your second equation. So what we do now is the following. We need to get rid of a in this case in order to get q on its own. To do that, what we do is we say that A is equal to negative 1 in this case. So therefore A is equal to negative 1. And if you substitute the negative 1 into A, you'll therefore get that Q is equal to positive 4. And then you solve both of the values, A, which is negative 1, and then Q, which is 4 in this case. Okay, let's move on. 5.3.1 asks you to calculate the length of CD. C all the way to D. Okay. Distance formula, guys, distance formula. So the first thing that you need to pick up is that from C to O, from C to O, this is graph F, you have to pick up that from there to there, it would be 3 units in this case. Not 3 units, 4 units, I do apologize, 4 units, because we just calculated it with this equation over here. And then from O to D, it's 3 units. So basically what we do then is, we then say 5.3.1, we're calculating the length of CD, so that would then be the Y value of C minus the Y value of D, which would then be 4 minus negative 3, and that would then give me, what am I doing? 7 units in this case. So from C all the way to D, it's 7 units in this case. Then 5.3.2, they ask us to determine the equation of a straight line through A and D. Determine the equation of a straight line through A and D. So over here, straight line equation is obviously y equals mx plus c. And then you need to pick up the following, is that the equation would be as follows. The y value for D is negative 3, and then the x value for A is negative 2 in this case. Okay? When I go write the gradient for the, for the equation for y equals mx plus c, I'll have to utilize the, the coordinates in this case. So, as the coordinates go, we will then say that y is equal to, for the gradient, it will be negative 3 over 2 x plus c. Okay? How do we calculate the gradient? It's easy. y2 minus y1 over x2 minus x1. I've also done a video on that you can go and watch. Then I take the coordinates for point A and I substitute them in to get the value of c. And then we'll calculate the value for c, that will be equal to negative 3 in this case. So therefore, the equation of the straight line would then be y equals negative 3 over 2 x plus, not plus 3, minus 3 I mean. And then if you just wanted to know how did I get to this, I gave you the formula now. You just use the points for A and for D to calculate the gradient, and then you'll get the gradient. So the coordinates for A and D, which you've calculated already. Okay, let's move on. Question 5.4.1. 5.4.1. They ask you to do the following. For which values is x? The following. Fx greater than 0, and then f decreasing. Fx greater than 0, and then where is it decreasing in this case. Okay, so if they talk about fx, they're talking about the parabola that's given to you over here. So where is that greater than 0? So from point A to point B is where you would be focusing on. Okay. Obviously, if this x value is -2, then the other part of the graph would be identical, but the signs would just change from negative to positive. So if you look at this graph, from -2 all the way to +2, that is where the graph will be greater than 0. So -2, x would obviously be in the middle because we're talking about the values of x, and then 2. Or you could write it as follows as well. You could say x is an element, and then you can say -2 and then 2 in that way as well. We'll mark both of them. Then they asked you, for which values of x is the f graph decreasing? Sorry, decreasing. It's for everything that is greater than 0. So 5.4.2, you'd say x is greater than 0, which means you could also write it as x element, and you can say 0 to infinity is where f would be decreasing. Obviously, because the two arrows go all the way down for the y value, and you do not know where it's going to stop in this case. Okay, so everything greater than 0, it would be decreasing in this case, from 0 all the way to infinity in that case. Okay. Sure. That's it for the graphs. We've got 3 more questions that we can quickly run through. Okay. Question number 6. Question number 6 is a question that focuses on the following equation. So it gives you the following. It says, oh, I hope you can see. The equation of the function, and then they give it to you there, passes through the points 3 and 2 and has a range of the following. So -infinity to 1 is a union to 1 to infinity, which is obviously just the opposite of each other. Then they say 6.1, determine the equation for G, and then the equation of H, the axis of symmetry of G, which has a positive gradient. Okay, so question 6.1.1. They gave you the equation. Here it is. And they said that it passes through points 3 and 2. You're going to use these points to calculate the equation. I'm telling you that. So these points are now utilized to find the equation. So 2 we put in there. We leave A where it is. We put 3 at the bottom plus Q there. Okay. We then will pick up the following. As what they've given to you here, you'll pick up that for the y value, there's a 1, which means that you can use that 1 to calculate the equation at the bottom, because that's the only other y value that's given to you, as well as that should be your asymptote, your horizontal asymptote. So 2 equals a over 3 plus 1. Now we just need to go and calculate a value for a. And if you calculate all of this, you'll get obviously 2 minus 1, which is a over 3, which is 1. And then you'll get a over 3 there. Multiply both sides by 3 over 1, which is the reciprocal. And you'll then get that a is equal to 3. So therefore, your equation will be gx. And that would be 3 over x plus the 1 that's given to you there. There's your equation. Okay. Now they say that for 6.2, you need to determine 6.1.2. You need to determine the equation of h. the axis of symmetry of G, which has a positive gradient. The axis of symmetry of G, which has a positive gradient. So basically, where would you have a positive gradient with the axis of symmetry of G? Where would it have a positive gradient? So hx is equal to x plus 1. That's where you'll have a positive gradient. So the equation of H, where the axis of symmetry of G has a positive gradient. And that would be x plus 1. Okay, so wherever you fold it, where would the gradient be positive? Question 6.2. Question 6.2 asks you the following. It asks you to sketch the graphs. Okay? To sketch the graphs. I'm not going to sketch it here. I will just show you how it has been sketched in this case. There we go. It's been sketched, done and dusted. Then 6.3 says, write the equations of the asymptote of f if fx is equal to negative gx plus 5. Negative gx plus 5. So this is 6.3. Let me just write fx equals negative gx plus 5. Like that. Okay. If you go and look at it, gx on its own, you've calculated already, which is the 3 over x plus 1. Okay? So, only thing we do is we go and substitute. So, first things first. We take it, we throw it over, so it becomes fx negative 3 over x plus 1. That's what we calculated. And then we've got plus 5 over here. Okay, sorted. Now we distribute the negative. So negative 3 over x minus 1 plus 5. So f is equal to negative 3 over x plus 4. So if I go and calculate this, I would know that x is equal to 0. Okay? So if x is equal to 0, then therefore, I would also then know that y is equal to positive 4. And that's where we'll give you the answer, the marks for that question. Okay. Sorted. Question number 7. Second last question, guys. And this has to do with financial math. Yay. So they say buy a Samsung J5 for only $229 per month. You have 24 months to pay, no deposit required. Okay. Question 7.1 says calculate the total amount to be paid over a period of 24 months. That's easy. Only thing you say is 229 times 24. You get an answer of 5,496 Rand. There we go. 1 mark. Question 7.2. The monthly installment quoted in the advertisement is calculated on a higher purchase, which means you use simple interest. Agreement, which charges interest of 7.5% per annum on the cash price of the cell phone. Show that the price of the cell phone is 4,779 Rand. Easy. This is the accumulated amount. You need to use simple interest. So A equals P 1 plus I times N. So all we do is, this is the accumulated amount. We need to calculate for P, which is the principal amount. They said 7.5, so it's 0.075. Or you could say 7.5 over 100. That's up to you. Times 2 years, which is the 24 months that you have over there. Divide both sides by 1 plus 0.075 times 2. Both sides, because it's an equation now. And if you do that, you'll get that P is equal to 4,779 Rand and 13 cents, which we see is true in this case. There you go, sorted. Okay, 7.3. Calculate the total interest paid over the period of 24 months if the cell phone is bought with a hire purchase agreement. Guys, you know what the accumulated amount is, which is the 5,496, and then you subtract the 4,779.13 that you just calculated. That will then give you a total amount of 716 Rand and 87 cents that you would pay in interest on the cell phone for that 24 months. 7.4, the cell phone is insured at 11.5% per annum of the cash price. The total insurance is calculated and then split up over 24 months. It is then added to the monthly installment. Calculate the new monthly installment if the customer wants to insure the cell phone. So, obviously, you would have to take, you have to take the monthly installment and then add insurance to that. So how do we calculate that? So for the insurance part, we do the following. We take the 4,779 because it was insured on the cash price, not the interest price. Times the 0.115. Remember, we took the 11.5%, put it over 100, which would give you this. And then we divide that by 12 because it was insured per year, not per month. And that would give you a total insurance price per month of 45 Rand and 80 cents. Then you would go therefore and say 229, which is the price of the phone, plus the 45 Rand 80 cents. Therefore, you'll then pay a total of 274 Rand and 80 cents for the phone per month if you insure it. Okay. Last question for financial math. 7.5. The cost of the cell phone is subject to inflation and increases to a cash price of 5,100 Rand after 2 years. Calculate the annual inflation rate. Inflation is bound to compound interest. So compound interest formula. Then they gave you the inflation price, which is 5,100. Originally or initially the price for the cell phone was 4,779.13. They want to know what the interest rate is, so you have to calculate for I, and that was over 2 years. So when you go and divide by 4,799.13, do it both sides. Oh, there we go. These would cancel out. Obviously, you'd leave that as is. You would then get I on its own. So what we'll do then is, let me go through the full process. You'll leave the 5,100 on the 4,779.13. We'll then have the bracket of 1i there. You'll square root both sides. Once we square root both sides, you get it like this. And then what we'll do is the 1 over here will carry over. And then you'll have I on this side. When you go and put this into your calculator, you must understand that I is over 100. Okay? Because it's interest rate. When you put this into your calculator, you get the following answer. I over 100 is equal to 0.0330,246, and then it carries on. Initially, we need to get rid of this 100. So we multiply by 100 over 1, both sides, which means your comma moves 2 spaces to the right. So therefore, your interest rate for that cell phone, or the inflation rate rather, for the cell phone would then be 3.30%. There we go. Inflation rate covered. So the only thing that you must remember is that inflation is with, what do you call it? Compound interest, higher purchase, simple interest. Which brings us to our last question for this paper. Question number 8, which is probability, ladies and gentlemen. And you can see all the Venn diagrams and stuff that's given to you. So just have a look at it quickly. Hopefully you can see everything. But remember, these papers are available on the GDE website as well. Okay, let's jump into it. Question 8.1.1. In a random physical science experiment, A and B are two different events. It was found that the event A, so they say event A, was 2 over 5. Beautiful. They say event B was 3 over 8. And they say event A or B, there we go, is equal to 5 over 7. Okay. They give you all this nonsense. Calculate event B. Calculate the probability of event B. So to calculate the probability of event B, we do the following. So event B is equal to 1 minus the probability of B. Okay? Which would then say 1 minus probability of B is 3 over 8. Which would then leave us with 5 over 8 as an answer. There we go. Done, dusted. Okay. What is this one? Okay. Then they say calculate the probability of event A and B. The probability of event A and B. So when we do the probability for event A and B, that would obviously now be question 8.1.2. 8.1.2. So the probability for A and B would be equal to event A plus event B. And you should know these formulas because they were taught to you. Minus the probability of A and B. Okay. So, event A and B. Sorry. I messed up the formula here. There should be OR. So, the probability for A or B is 5 over 7. For A, it's 2 over 5. Plus for B, it is 3 over 8. And then you sit with minus the probability of A and B in this case. Okay? We need to calculate for A and B. If we add all of this together and do what we're supposed to do, you should get the following. So I'm going to bring this over. So you get P, A and B to make it positive. 2, 5 plus 3, 8. Minus 5 over 7. So the probability for A and B is then equal to 87 over 280, which gives you a decimal value of 0.31. There we go. Like I said, these formulas were taught to you, so you should know what's happening. Question 8.2.1. They give you Venn diagrams and they say the Venn diagrams below represent different scenarios of events A and B. Write down the probability of the shaded region for each of the diagrams. So 8.2.1, they want you to write down the probability for the shaded regions. So for 8.2.1, they say there that when we write down the probability for this, you need to pick up the following. That will say probability for A, not B, let's go there. Or you could say the probability A and B. Remember, it's union and intersection. So in this case, it's focused on the intersection. So if you've got an intersection, you'd use the intersection symbol. If it's not part of the intersection, you use the union symbol like we'll do in the next question. So 8.2.2, if you look at this question, you would see that probability for A and B over here is a union, or you could write it as probability for A or B in this case, because it's the symbol that was used was union. Then 8.2.3, it's the one at the bottom here. The probability there would be intersection again. So A, B, or you could write A and B in this case. Then moving on to our final question. So which diagrams in questions 8.2 to 3 represent mutually exclusive events? The only one for, out of these three that does actually represent mutually exclusive events would be question 8.2.3 in this case, mutually exclusive events. Okay, and that is that, ladies and gents, for this evening's paper discussion. Thank you for tuning in. Thank you for sitting through an hour-and-a-half session. I hope that this will assist you. I hope that I've been very detailed in answering these questions for you and with you, and that you've actually learned something out of it. Thanks for tuning in again. Thanks for always supporting. I really do appreciate it. Until we meet next time, have a good evening further and stay safe.